Hey class, we're back with our final video of 8.1 and we're going to look at example 3. So it's solving a problem involving rates. So when making a decision about buying a vehicle, fuel efficiency is often an important factor. The gas tank of Mario's new car has a capacity of 55 liters, and the owner's manual claims that the fuel efficiency of Mario's car is 7.6 liters for every 100 kilometers on the highway. Before Mario's first big highway trip, he sets his trip meter to 0 kilometers so he can keep track of the total distance he drove. He started with the gas tank full, and each time he stopped, he filled up the tank completely. He recorded the distance he had driven and the amount of gas that he purchased. So we can see that he has essentially two fill-ups. He's traveled on the first fill-up 645 kilometers, and the amount of gas he ended up having to purchase in liters was 48 liters. He then continued on his trip. Now we're not resetting the 645. He continued up until he got to 1,037 kilometers, and then he purchased another 32.1 liters. So the question is, on which leg of Mario's trip was his fuel efficiency the best? Well, I think the best way to do this is to express it as a unit rate. So you'll notice up here that they compare 7.6 liters per 100 kilometers. So I want to see if we could actually maybe figure that out using unit rates. Unit rates would probably be the easiest way to do it, but if you try and get the stat of per 100 kilometers, you have to kind of do a little bit of extra steps. So I'm going to show you that. So going right to it, let's recognize that this 645 is representing kilometers and that this 48 is representing liters. So if I want to set up a ratio or a rate conveying those two things, and I want it to be liters per kilometer, what I'm going to state is that my first rate, or I'm going to say R1, is equal to 48.0 liters per 645 kilometers. Now, let's just do this problem the easy way for the first time. So what I'm going to do is I'm going to take this and I'm going to change it into a unit rate. So I'm going to take 48.0 liters and I'm going to get 645 kilometers and I'm going to do a division there. So 48 divided by 645 gives me 0.744, and I'm going to round that to 2. So actually it's 0.7, let's go to fourth decimal place. So 0.744 liters per every 1 kilometer. Okay, so now I have a unit rate, and I'm just curious about how well this compares with my advertised rate. So what I want you to think about is that if I wanted this to be 100 kilometers on the bottom, remembering that this just represents a fraction, so let's write it out so you can see it that way. And that's 1 kilometer. If I wanted to change the denominator of this so that the denominator was 100 kilometers, what is it I would have to be multiplying by? Well, I'm only allowed to multiply by one number without changing anything, and that number is 1. But I'm going to multiply by a really clever form of 1. So I'm going to multiply by a scalar of 100 over 100. What's going to happen is that's going to move my decimal place twice to the right, and I'm going to end up getting 7.44 liters per every, and that will change this to 100 kilometers. So you can see how I'm actually not getting the advertised fuel mileage, and that is typical of advertising companies. You'll never really see yourself get that mileage that they advertise. Now, let's go to the second piece of the trip so we can figure out on which leg he actually did better. So let's call this rate 2. And again, I'm going to take my 32.1, and that's liters, and that's per. Now here comes the tricky part. I have to recognize that there were already 645 kilometers on the odometer. So how do I figure out how much he traveled in the second leg? Well, I'm just going to take 1,037, and I'm going to subtract off that initial 645, and that brings me to 392. So the difference was actually 392 kilometers on that second leg. So again, converting that to a unit rate, I'm going to take my 32.1 and divide it by 392. And I actually, on this, I can see now that this is fictitious. I got 0.081, and it would actually round up to 9. And that would be liters per kilometer. And so again, if I wanted to take that unit rate, which I could express as a fraction, 0.0819 liters per 1 kilometer, and if I wanted to again make that over 100 kilometers, I'm simply going to multiply by a clever form of 1. And this would move my decimal twice to the right, so I end up getting 8.19 liters per 100 kilometers. And so you can see this is actually above the advertised fuel economy. And so that's really, really cool. So this is just one example of how you can solve problems involving rates. Which was his best fuel efficiency? Well, it was obviously on the second leg of the trip.